Another critical dimension of aging that supports viewing it as a malnutrition-driven phenomenon is the gradual breakdown of proteostasis, the body's ability to maintain the quality and functionality of its proteins. Proteins are the molecular machines and structural scaffolds of every cell, and their constant renewal is essential for cellular health. This turnover process relies entirely on a sufficient and balanced supply of essential amino acids, which cannot be synthesized by the human body and must come from the diet. When dietary protein is chronically inadequate, or when the amino acid profile of consumed protein is unbalanced, the raw materials required to replace damaged or worn-out proteins simply aren't available. This amino acid shortage leads to a backlog of damaged or misfolded proteins, which accumulate inside cells and tissues. These defective proteins interfere with everything from enzyme function to cell signaling, and their buildup has been linked to many age-related disorders, including sarcopenia, neurodegeneration, and organ fibrosis. Yet rather than representing an unavoidable, programmed disease of aging, these outcomes can be more accurately seen as the direct result of a prolonged deficit in the fundamental nutritional building blocks required for maintenance and repair. This view is strongly supported by research showing that older adults who consume diets rich in high-quality protein, especially those with a balanced amino acid profile, maintain better muscle mass, strength, immune function, and even cognitive abilities compared to peers with lower or inadequate protein intake. Studies of populations with exceptional longevity, such as those in Okinawa or certain Mediterranean regions, consistently reveal diets that include sufficient, bioavailable protein sources throughout life, allowing continuous renewal of tissues and a lower burden of misfolded proteins. Furthermore, modern evidence points to the synergistic importance of both total protein quantity and amino acid diversity. Diets that provide adequate leucine, for example, help activate mTOR signaling pathways that trigger muscle protein synthesis, crucial for counteracting sarcopenia, one of the most visible and debilitating signs of aging. When diets are not only low in total protein but also skewed in amino acid composition, as can happen with heavily processed or limited food choices, the bottleneck in proteostasis becomes even more severe, accelerating tissue dysfunction. Reframing the breakdown in protein turnover as a nutritional problem rather than a mysterious or inevitable disease offers an empowering paradigm. It highlights practical strategies to slow or prevent age-related decline through consistent, adequate intake of high-quality protein sources across the lifespan. It also encourages a more holistic approach to aging, one that seeks to correct modifiable lifestyle factors instead of prematurely categorizing natural declines as pathological processes requiring pharmaceutical intervention. Ultimately, the failure to sustain proteostasis underscores the broader thesis that aging should not be defined as a disease in itself, but as a reflection of cumulative, subtle malnutrition. The inability to continually supply the body with the essential amino acids it needs to repair and regenerate leads to the visible and functional signs of aging. Addressing this nutritional gap can profoundly alter the trajectory of aging, preserving physical performance, metabolic health, and independence well into advanced age.